Hello students. So in this session we are going to discuss intensity transform. The intensity value transformation may be done in two different domain. One is spatial domain and other is transform domain. In spatial domain we process the pixel values directly along with its neighbors. In transform domain first we transform the pixel value in different domain like applying Fourier transform like in frequency uh, amplitude may be transformed into frequency domain, and then we change the frequency and get back to pixel values. So in intensity domain we shall discuss some of the techniques. So here mathematically we can write that you have f x comma y, that is 2D image, grayscale image, and if you apply a transform, so it will be converted into new kind of image that is represented by g. So g is equal to capital T of f. So here the operator t is the transform. For example, let us apply a thresholding. In thresholding, what we do, let us say we have one grayscale image. The value, let us say 1, 5, 6, okay, 2, 0, 1, 8, 5, 4. Now, if we apply the transform is say g is equal to 0 if f value, the value of f is less equal to 2. Okay, otherwise 1 else. So applying the transform, this would become so 1 is less equal to 2, so this is 0, this will be 0, this is 0, this is 0, and remaining these all will become 1, 1, 1, 1, 1. So this is called thresholding. So we have a threshold limit here that is 2. So if the value of f less equal to 2, make it 0, otherwise 1. So here the operator is called thresholding operator. Okay. So the intensity values got transformed this way. Second example, let us say getting the negative or inverse image. Getting inverse image, here the transform we can write like g is equal to 255 minus f. Okay. So here we consider that the grayscale level is 0 to 255. So we subtracted the value of f in the highest value. So g is equal to 255 minus f. So how it will become? 255 minus 1, that will become 254, 250, okay, 249 and so on. Okay. So simply subtract the value in 255. So you will get the inverse image or negative image. Another method is called log transform. Here the transform is such that g is equal to some constant and log of f. But here f sometimes may be 0 and log 0 may be undefined. So put here 1 plus f. So in this case, if your original pixel value, this is your f, if you apply log of that, and here it depends upon this base value, okay, log 1 plus f base r. So if you put base value smaller than 1, and if you put the base value bigger than 1, so the graph will look like this. If base value less than 1 and base value greater than 1, if you keep on increasing the base value, it will look like this. So changing the base value and constant, you can change the pixel values. So considering this diagonal line, like this line as the original pixel values, and the remaining these are transformed. In this case, what you can see, the smaller values are decreasing very nominal, but higher value, like smaller value increasing with very small quantity, but larger value is getting increased by larger quantity. Okay, that is sometimes called you know stretching, color stretching, or contrast stretching. Similarly, in this case, the smaller pixel value increasing with larger quantity. On the other hand, the large value uh, increasing very with, okay, smaller and smaller rate. So this you can say that contrast stretching. On the other hand, here uh, it is in reverse of contrast stretching. So using log transform, you can uh, do such kind of transformation. The next one, the next transformation is gamma transform. In gamma transform, the transformation is like g is equal to some constant and the original pixel value f to the power r. Okay. Here we are taking log in log transform. In gamma transform, we are raising with exponent. In this case, if you plot, this is the original pixel values. Now, if you put gamma values greater than 1, then the transformation will be like this. If gamma value less than 1, it will go on like this. So it looks like similar like log transform, but this is another way of doing the transformation. So this way we have discussed some of the uh, spatial intensity transform. In the next session, we shall see another transform like histogram equalization, And in the subsequent classes we shall also discuss applying the spatial filter. So these topics we shall see in the subsequent classes. Thank you.